Hey everybody, Mr. Wader here, and today we're going to be going over valence electrons and Bohr models. To start, the topics we're going to be covering: period and group number, determining the number of rings or shells that are going to be in atoms, and determining the number of valence electrons. And then we'll have some practice examples at the end. Okay, to start, what do you notice about this picture? There's a bunch of numbers in there. What do those numbers mean? If you take a look at the inside of the atom, and yes, that's calcium, element number 20. If you take a look at the inside there, there's numbers 1, 2, then there's a second circle and it counts up to 8. There's a third one that counts up to 8, but you'll notice it doesn't go all the way around the circle. And then there's a fourth one that counts up to 2. Each of those numbers represents an electron, and calcium is element number 20, so that means it should have 20 electrons if it's neutral. So if you add up all those numbers there, 2 on the inside, 8 in the second ring, that's 10. Add another 8 for the third ring, that's 18. And add the 2 on the outside and you get 20. So this picture right there is representing the electrons in calcium, all 20 of them. So you can find that out by looking at the periodic table. Each element is in a row, which is called a period, which is why the table is called the periodic table, because it's the table organized by period. And each element is also in a column, which is called a group. And if you look at the periodic table I supplied you with, it has the group numbers and the period numbers listed there. The group number gives you the number of electrons on the outside ring, and the period number gives you the number of rings. If you take a look at calcium, calcium is in the fourth row on the table, which is why it has 4 rings there, also known as shells. And it is in the second group, group 2, so that means the outside ring should have 2. For the elements that we're going to use, we're only going to go up to 3 rings, and we're only going to be using up to 8 electrons per ring with the elements that we use for this. So, like I said, the valence electrons are on the outside. Valence electrons are determined by its group number. So calcium has 2 valence electrons because it's in group 2. Valence electrons are the ones that normally do chemistry, and because those are the ones that we're going to be using to understand reactions and things like that, those are the ones that we care about. So, another way to visualize this is by period, and then I'll show you by group. Like I said, each row is a period, and the elements in each period have the same number of shells. So the first period, it's red. Those are the first 2 elements. They both have 1 ring or shell. If you look at the second period, each element in that row has 2 rings, and third row, all of them have 3 rings. Fourth row, they have 4 rings, etc. Groups are vertical. Those are the columns. Each column is called a group. Each element in a group has the same number of electrons in the outside shell there. And those are the valence electrons. Those are the ones that we care about. So group 1 has 1 electron, group 2 has 2 electrons, group 3 would have 3, 4 would have 4, etc. If you notice, group 3 on your periodic table is labeled as 13 and 3a. We're getting the 3 from the 3a. The only element that breaks this rule is helium, and that's because helium is in group 8, but it's only the second element, 18 or 8, depending on how you classify it. But because it's only the second element, it's only counted up to number 2, so it can only have 2 electrons. The transition metals are all those ones in the middle there. We are not going to be using those, and that is because transition metals don't follow the general rules that we're going to learn, so don't worry about those ones. Okay, so let's do some practice. If you take a look at the table on the right there, which is a simplified version, you have the group numbers there. So the first element, lithium, if you take a look at lithium, lithium is right here, element number 3. That means it is in group 1, and it is in period 2. If you look at silicon, what you'll see for silicon is that it is over here, it's element number 14. It's in group 4, or 14, and it has 4 valence electrons, which makes it group 4 as well. And it is in period 3. If you do the same thing for oxygen, oxygen is in, it's going to have group 16, so 6 as well. And it is in the second row, second period. If you look for carbon, it's 2 spots to the left, so it is also in the second row, so period 2. And we're going to use group 4. Boron is 1 to the left, group 3, same row, same period, and then neon is off to the right. If you fill those in, you've got the period and group right there. Those correlate directly with the number of valence electrons and rings. So that means that everything in period 2 should have 2 rings, and everything in period 3 would have 3 rings. So here are the pictures for those elements there. Lithium is the first one. It has 2 rings and 1 valence electron, so that means 1 on the outside ring. Silicon has 3 rings because it's in the third row, and it has 4 valence electrons because it's in group 4. Same thing is true for oxygen. It's matching its group number. So each of these pictures directly matches the information in the table to the left. And that is because of its place on the periodic table. So, for some practice here, we're going to try and do this with a couple of elements. So, sodium. If you take a look at sodium, sodium is in group 1. It's in period 3. Since it's in group 1, that means it should have 1 valence electron. And since it's in period 3, that means it should have 3 rings. If you take a look at the picture there, it is in the third row, has 3 rings. It is in group 1, so it has 1 on the outside. Next up is hydrogen. Hydrogen is element number 1. If you take a look at hydrogen's place on the table, element 1 is in group 1 and period 1. So that is hydrogen, 1 shell because it's in the first row, 1 valence electron because it is in the first group. And there's its picture right there. If we try this with beryllium, beryllium is element number 4. It is in the second group, and it is in the second period. So beryllium, 2 shells, 2 valence electrons. There's its picture. Next up is sulfur. And if you want to practice these, you can write your answers down. If you have a notebook for class, you can use that. Otherwise, you can just draw it on a blank piece of paper, whatever works for you. Try this one really quick. So sulfur is element 16. It is in group 16 or 6, depending on how you want to label it. And it is in the third period. So what does that mean for sulfur? If you want to pause the video to get more time, you can. But here is the answer. So S is sulfur, third period, so it'll have 3 shells. Sixth group, so it'll have 6 valence electrons. There's the picture right there. And this is the last one. This one breaks the rule. Helium is the name of the element. So if you want to pause the video to give this one a shot, feel free. Helium is in group 18 or 8, but it's only the second element. So because of that, the only electrons that it has available are 2, because it's the second element. It only has 2. So that means helium, which is in the first period, has 1 shell, and it has 2 valence electrons. This is the one that breaks the rule. Alright, with that in mind, the assignment that I'm going to be giving to you to try and practice these is to draw those diagrams for 4 elements. And I'm going to ask you to try and draw those diagrams for lithium, which is element number 3, aluminum, which is element 13, nitrogen, which is element number 7, and fluorine, which is element number 9.